Welcome to my channel Mathematical Clinic of Subhasja. This is the second lecture of permutation and combination. In last lecture we studied two important principles, though were addition theorem and multiplication theorem of basic principle of counting. In the addition theorem we learned that if a mission completes in single level and we have different independent options to do it, then we add the options to get the answer. And in multiplication theorem, if a mission completes in more than one level, then we multiply the options to get the answer. Today we are going to do some of the numericals where we implement these principles. First numerical I am going to write here is, question number 1 is, how many three different digit numbers can be made using digits 1, 2, 3, 4, 5 and 6. That's the question. It's a very simple and even very interesting question. You are given with 6 digits 1, 2, 3, 4, 5 and 6. Actually given digits are 1, 2, 3, 4, 5 and 6, and you have to make 3 different digit numbers. It means number like this 123. There are 3 digits, first, second, third, and all are different. 1, 2, 3 are different. We have to make this type of numbers using digits 1, 2, 3, 4, 5 and 6. 7 cannot be used there, 8 cannot be used there, only 1, 2, 6 can be used, and we have to make this type of number. We have to find exact number of such numbers can be made. Actually here we can see that a single number of 3 different digits can be made by doing work at 3 places: first place, second place, third place. In the junior level we had studied that this is the unit place, this one is the tens place, and this one is the 100 place. So you will have to work at 3 places: ones place, tens place and hundreds place to get a single number of 3 different digits. So it is a multiple level problem. Here we'll have to apply the multiplication theorem, first level, second level, third level. Now our target is to find the option at each level. Actually, to fill the unit place, how many choices are available? 1, 2, 3, 4, 5 and 6. Any one of them can be kept here. So how many choices are there? 6 choices to fill the unit place 1. But as we are willing to have different digit number, for example, if you put 6 here, then 6 cannot be put here. If you put 6 here, then it will not be different digit number. So to fill the next places one, you will be lacking with one number. For example, if 6 is kept here, then 6 cannot be kept here. If 5 is kept here, then 5 cannot be kept here. So to fill the second place one choice reduces. There were altogether 6 choices, one is kept here. So now you are left with 5 choices to fill the tens place. Likewise, one choice reduces to fill the next place one. Altogether there were 5 choices, one reduces, then you are left with 4 choices at the hundreds place. And cause the work has been completed in multiple level, first level, second level, third level, 3 level 1, we apply the multiplication theorem. We multiply the options to get the answer. So the answer becomes 6 5 are 34 120. Very simple. Again I am going to tell you from the beginning. Actually the question has told you that you have to make 3 different digit number. It means the numbers like this 123, and you are given with digits 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6 can be used to form this type of number. And we come to the conclusion that to make a single number of 3 different digits, we have to pass through three places: ones place, tenth place, and hundred place. I have started from here. You could start from here as well, but I have started from here. To fill this place one, we have six choices. Any one of these 1, 2, 3, 4, 5, and 6 can be kept at this place one. So six choice for the unit place one. And cause it is different digited number, cause the digit must be different, the number which is kept here cannot be kept here. So one choice reduces for the tens place one. Altogether there were six, one reduces, that is why you are left with 5 digit to fill the second place one. And by the similar manner you reduce one from 5 and left with 4 choices to fill the 100 place one. And because the work has been completed in 3 level, multiple level, we have multiplied the options to get the answer. So the answer of this question is 120. Now one thing I am going to tell you, if the question would not have told you different digited numbers, or the question would have told you that the digit can be repeated, then you could also make the number like this, 222. Same digit 2 could be placed at ones place, tenth place, and 100 place. In that case, the choices at the unit place would be 6, and even the choices at the tens place would be 6. Choices would not reduce. If the question would have told you the digit can be repeated, that choice does not reduce. And so the 100 place could be also filled by 6 ways, and at that case the answer will be 6 multiply 6 multiply 6. That would be the answer of this question. So we came to the conclusion that there are two types of this type of numerical. In one, digit can be repeated, and in another digits cannot be repeated. If digits can be repeated, then choices does not reduce. There were 6 choices altogether, here 6 also, here 6, and here 6 also, and we apply the multiplication theorem to get the answer. But if different digited number, if digits are not allowed to repeat, then choices reduces. For the first place one, 6 choices. For the next one reduce, we subtract 1, get 5 choices. For the second place one, and again if you reduce 1 from the 5, then you are left with 4 choices from the third one, and we again multiply the multiplication theorem to get the answer. That must be remembered, whether the repetition of digits is allowed or not allowed. Move to the second question. I am going to add one single word in the same question. How many 3 different digited odd numbers is added here, everything same, otherwise can be made using digits 1, 2, 3, 4, 5, and 6. Actually, again you are given with 6 digits, 1, 2, 3, 4, 5, and 6. Again you have to make 3 different digited numbers, so you will fill 3 places: first place, second place, third place. It means ones place, tens place, and 100 place. Again, just like this, digit cannot be repeated. Different digited numbers has been asked in the question, but this question is different than the last question in the matter that now we are required odd numbers, not simply numbers, odd numbers. Can you say that 123 is odd number? Yes, you can. How can you say 123 is an odd number? Because last number is the number at the unit place is odd number 1. Is 132 odd number? No, because the last number 1 is the even number 1. So odd or even number can be justified looking towards the last place. It means the ones place. If the number here is odd, then whole number is the required number is odd. If number here is even, then required number will be even. But the question has asked us to find the odd number. So in this place one, in the unit place one, only odd numbers can be kept. Only odd numbers can be kept. And how many odd numbers are there altogether? So to fill the last place one, how many choices are there? Only odd number can be kept here. 1 is odd, 3 is odd, 5 is odd. So the last place can be filled by 3 ways. And for example, suppose 1 is kept here, then 1 cannot be kept here because the question has told you to find the different digited number. So for the next place one, how many choices will be there? There are altogether 6 number. One of them is kept here, so you are left with 5. And for the next one, again one choice reduces, you will be left with 4 choices for the 100 plus 1. And hence by the multiplication theorem, the answer will be 4 multiply 5, 20 multiply 3 equal to 60. 60 is the answer of this question. Once again I am going to deal from the beginning. The question have told you to make 3 different digited odd numbers by using digits 1, 2, 3, 4, 5 and 6. Actually the given digits are 1, 2, 3, 4, 5 and 6. You have to make 3 digited number, different digited number and even odd different digited number, because the odd number can be justified looking towards the unit place one. This place has the restriction. This place can be filled by only odd numbers, and we are given with just 3 odd numbers 1, 3 and 5. So the last place can be filled by 3 ways, because you have to make the different digited numbers. This place can be filled by 5 ways, and again one choice for this place reduce, and you are left with 4 choices. So by multiplication theorem, the required number of ways becomes 4 multiply 5 equal to 20 multiply 3 equal to 60. Let us move to the third question one. How many numbers of different digits between 200 and 400 can be made using digits 1, 2, 3, 4 and 5. Again concentrate here. You are given with 5 digits 1, 2, 3, 4 and 5. And which type of number are to be made? Numbers between 200 and 400. It means number greater than 200 and smaller than 400. Very simple. We can say that any number greater than 200 and smaller than 400 is of 3 digits. Now one thing you must remember is whether the digits can be repeated or not. The question has already used different digited numbers, so digit cannot be repeated. So choice will reduce. The choice for this place be something, then the choice for this place will be one less than that thing. And the most important thing is this one is the ones place, this one is the tens place, and this one is the hundreds place. The most important thing is where is the restriction. In the last question there was the restriction at the unit place, cause even and odd can be justified looking towards the last place one. But here where the restriction is, you have to make number greater than 200. So 2 can be kept here. 3 can be kept 100. 300 something is also greater than 200 and smaller than 400. But 4 cannot be kept here. If you keep 4 here at the 100 place, then the number will be greater than 401, not smaller than the 401. So 4 and 5 cannot be kept at this place, and even 1 cannot be kept at this place. If you keep 1 here, then it will be 100 something. 100 something is not greater than 200. So we are able to see that there is the restriction at the 100 place. 1, 4 and 5 cannot be kept at the 100 place one, because if 1 is kept, the number will be smaller than 200. The condition will be damaged. If you take 4 and 5 here, number will be greater than 400, and again the condition will be broken. So you can keep here only 2 and 3. So to fill the first place 100 plus 1, you have just two choices. And again altogether there were 5 numbers. You need the different digit numbers. You will be left with one number of them is kept here, so you are left with 4 numbers to be kept here. And again one choice reduces for the last one, so 4 minus 1 equal to 3 choices for the unit place 1. Hence by the multiplication theorem, required number of numbers becomes 3, 4 the 12 to the 24. So 24 such numbers can be made. Again I am going to deal from the beginning. The question is, how many numbers of different digits? Different digits means very simple. I had told you in the beginning that there are two types of numericals. In one, number can be repeated, digit can be repeated. In another, digit cannot be repeated. If digit can be repeated, then twice for each places will be same. If digit will not be repeated, then the choices reduces. You can see here 6 after 6 5 after 5 it is 4 reduces. So this is the second type of numerical. It means the choices will reduces. But here there is another restriction as well. The restriction is you have to make numbers between 200 and 400. It means the number greater than 200 and 400. Numbers greater than 200 and smaller than 400. So 1, 4 and 5 cannot be kept here, because if you put 1 here, then the number will be 100 something. That will not be smaller than 200. Sorry, greater than 201. If you keep 4 or 5 here, then the number will be 400 something or 500 something, which will damage this condition one. Number should be smaller than 400. That would be the number greater than 400. So 1, 4 and 5 cannot be kept here. So you are left with just two choices for the 100 plus 1. This place can be filled by only two ways. There will altogether 5 numbers. One of them is kept here. So 4 numbers left for the second place 1. And again 4 minus 1 equal to 3 numbers for the third place 1. Multiple level problem. We have multiplied the options to get the answer. Now I am going to tell you in detail, in short, that there are two types of numericals where we use multiplication theorem. One is where there is no restriction, like question number 1. There is no restriction. If though no restriction, here just you have to make numbers, neither even numbers nor numbers divisible by 5, nor the numbers between 200 and 300, nor the even or odd numbers. No restriction was there, so we started from this place. We could start from any place we please. If there is no restriction in the question, we can start from any place we please. But if there is the restriction, here there is the restriction at the unit place, here there is the restriction at the 100 place. If there is the restriction, first of all we will have to justify where the restriction is. We will have to fill that place first, only after the remaining places to get the answer. So don't forget, if the problem is the problem of restriction, you will have to find where the restriction is. We will fill that place in the beginning, only after the remaining places to get the answer. We are going to do some more examples. Question number 4. How many numbers divisible by 5 can be made using digits 1, 2, 3, 4 and 5 if repetition of digits is not allowed. Again you can say you have to make how many numbers divisible by 5 can be made using digits 1, 2, 3, 4 and 5. But the repetition of digits is not allowed. Now here the question has not told you to make how many digit numbers. So first of all we think how many numbers are given. You are given with how many digits are you given with? You are given with 5 digits. 1, 2, 3, 4 and 5. So three types of numbers can be made. Sorry, 5 types of numbers can be made. Numbers having only one digit, number having two digits, number having 3 digits, number having 4 digits, and number having 5 digits. Because you are given with just 5 numbers and different digit numbers are required, we cannot make number having more than 5 digits. Now we can say that you have to make number divisible by 5. How can you justify whether the number is divisible by 5 or not? Actually, let us consider number 5. Is 5 divisible by 5? Yes. Thereafter 10. Is 10 divisible by 5? Yes. Thereafter number 15. Is 15 divisible by 5? Yes. Thereafter number 20. Is 20 divisible by 5? Yes. We can justify that a number is divisible by 5 looking the unit place one. If 5 or 0 is there at the unit place, number is always divisible by 5, otherwise number is not divisible by 5. So we can say that, but 0 is not given here. So we can say that the number will be divisible by 5 only if 5 will be there at the unit place 1. So how many one digit such numbers can be made? Only one, because only one choice is there. Only 5 is one digit number which is divisible by 5 can be made using digits 1, 2, 3, 4 and 5. Now let us move towards the second one. Here there are two places. There is the restriction at the unit place. How many choice for the unit place 1? Only one choice. Only 5 can be kept here. And how many choice for the next place 1? Altogether there were 5. One of them is kept here, so you are left with 4. So 4 multiply 1 equal to 4 such two digit numbers are possible. Let us use the same manner here. Only 5 can be kept here, nothing else. So for the unit place 1 there is only one 5. For the 10 plus 1 you are left with 4. For the 100 plus 1 you are left with 3. So 4 3 are 12 into 1 equal to 12 altogether. Likewise here unit place can be filled by only one ways. Only 5 can be kept here. This place can be filled by 4 ways, 3 ways and 2 ways. So altogether 2 3 are 6, 4 are 24 such numbers are possible. Here this place can be filled by only one way. This by 4, this by 3, this by 2 and this by 1. So altogether multiply all of them. 4 3 are 12, 2 are 24 such numbers are possible. Let us add all of them, we will get the answer. 24 plus 24 equal to 48 plus 12 equal to 60. 4 plus 1 65. 65 such numbers are possible. Once again I am going to deal from the beginning. Actually the question has told you how many numbers divisible by 5. Numbers divisible by 5. There is the restriction. Actually number divisible by 5 consists 5 or 0 at the unit place 1. You can see here all the numbers are divisible by 5. So at the unit place there is either 5 or 0. Getting it? So unit place can be filled by only two ways. You can use 5 or 0. But 0 is not given here. These options again cancelled. So unit place can be filled by only one way because you are just given with 5. So if you make one digit number then it will be just 5. Two digit number then last place can be filled by one way and first place can be filled by altogether 5. One is reduced then 4 ways. Likewise